Alright, so this is the section 11.1 lesson video for physical science. So remember, I'm not going to attach all my videos to my website, so just subscribe on YouTube and that way you'll have all my videos in the same place at one time. Alright, so chapter 11 is on motion, so like I said, we're going to cover section 11.1 right now. So 11.1, we're going to discuss the difference in distance and displacement. So to describe motion accurately and completely, a frame of reference is necessary. A frame of reference is a system of objects that are not moving with respect to one another, and relative motion is the movement in relation to the frame of reference. The problem is, motion is dependent on who is trying to describe the motion. And so in the next slide, we're going to look at a picture on how the frame of reference is very important. So it says, are the people in the car moving? Well, if the frame of reference for whether or not the people in the car are moving are the people themselves, like let's say if we ask this lady, is this man moving? Or this man, if this lady's moving. Well, if they're in the car together and they're moving at the same speed, if they look over, it doesn't look like they're moving to each other. However, if there was a car that people were driving down the road and somebody sitting on the side of the road looked at those people, and then we said, are those people moving? To the people who are still on the side of the road, it would look like the people in the car were moving. Okay, so it's all about frame of reference. Here, the frame of reference, they're both moving at the same speed. So if they look at each other, it appears there's no movement. Whereas here, these people are stationary on the side of the road, and the people driving past would appear to be moving. So that's why frame of reference is important when we're describing motion. So distance is the length of a path between 2 points. It is helpful to express distances in units that are best suited to the motion you're studying. So for example, let's say we start here in Venice and we travel through all these different places and come back around to Venice. Then our path taken is our distance, so we'd have to add up all these amounts. Now, what would we measure something like this in? Well, in America, of course, we would choose miles, but in science, we don't use units like that. So what we would pick in this example for very long distances like that is we would use kilometers. Okay, we don't really use American units that often, so let's try to stay away from things like miles and inches and things like that. All right, so distance is the path taken. So let's look at some units. So what unit would you use to measure the length of someone's hair? Now technically, I guess you could argue, well, it depends on whose hair you're measuring, if somebody has like a buzz cut or something like that. So what would be a good unit to measure someone's hair? Most likely centimeters would be your best. Okay, and again, if they had a buzz cut, you may need to go to millimeters, but you know, if it's just a normal length hair, then centimeters would be your best unit. What unit would you use to measure from McDonough to Atlanta? Well, again, when you have a long distance like that, our best unit would be kilometers. Okay, so again, let's stay away from things like miles and inches, things that we use in America, because we don't focus on those in science. And then what unit would you use to measure the length of a room? Again, the American unit you would probably pick is feet, but we're not going to use that. So the best unit to measure just the distance across a room would be just meters. Okay, so you need to familiarize yourself with these prefixes, like centi means small, it's 1/100th. Kilo is a large unit, it means 1,000. And meters is, of course, our base unit for length or distance in science. So, what's the difference in distance and displacement? Well, distance measures the path you take. Displacement is the direction from the starting point and the length of a straight line from the starting point to the end point. So for example, if you're going from here to here, this is your displacement, even though in real life, you may have to drive to get to an airport over here, and then fly over here first and have a layover, and then fly over here, and so you may have a much longer distance. Your displacement is always the shortest path, because a straight line between 2 points is your shortest path. So distance is the path you take. Displacement is a straight line from start to finish. Now, can your distance and displacement be the same? Well, if your path is from start to finish in a straight line, then they would be equal. All right, so how do we combine displacements? Well, displacement is a vector. So let's talk about what a vector is first. So a vector is a quantity that has a magnitude, which means like an amount or a number, and a direction. So a vector for displacement might be I traveled 20 kilometers north. That's an example of a vector because we have the 20 kilometers, that's our magnitude, and the direction is north. When you add displacements, we have to use vector addition. So I'll show you how to do that on the next slide. So when you add using vector addition, the direction of the vector is very important. All right, so when two displacements represented by two vectors have the same direction, you add their magnitudes. So see how these are both pointing to the right? So we would say 5 plus 5 means we're going 10 to the right. All right, if two displacements have opposite directions, the magnitudes subtract from each other. So here we have 5 to the right, and here we have 5 to the left. So I would say 5 minus 5 means overall we moved nowhere. So it'd be like if I started here, walked across the room, and then walked right back. So my total displacement is 0 because I ended where I started. Okay, so here we have 5 pointing to the right plus 10 pointing to the right would be 15 total. Here we have 5 to the right but 10 to the left. So what that means is we overall move to the left 5. All right, and here we have 5 to the right and 15 to the left. So of course that means overall we traveled 10 to the left. And then here it shows that you can also do up and down. So this would be like a north and a south thing. So if we have 10 moving up and 5 moving down, we overall moved 5 up. So that's how vector addition works, is you just have to keep in mind when they're in opposite directions, they kind of cancel out, assuming they're the same magnitude, so we need to subtract instead of add. All right, so here's just a picture to remind you the difference in distance and displacement. So here's our start, here's our end. Now this is the path taken. Say we were going on a hike or something. We're just kind of wandering around in the woods. So that's the path taken. So that would be our distance. This is our displacement, a straight line from start to finish. All right, so distance is the path taken. Displacement is a straight line from start to finish. That's the important thing to remember. All right, so let's look at this section assessment. So what is the frame of reference and how is it used to measure motion? So remember, frame of reference is a group of objects that are not moving with respect to one another. Okay, so remember the frame of reference, like I said, for the people sitting on the side of the road, looking at the people driving in the car as they pass. That's an example of frame of reference. So how is it used to measure motion? We base our motion on the frame of reference. Okay, so we base our motion on the frame of reference. So remember, if the two people are in the car together and they look at each other, they appear to not be moving. However, if someone's stationary on the side of the road and that's our frame of reference, the people in the car are moving. Okay, so we base our motion on the frame of reference. So, how are distance and displacement similar and different? Well, the way they're similar is distance and displacement are the difference in your starting point and your finishing point. So we have a starting point, we have an ending point in both distance and displacement. So that's how they're similar. But how are they different? Well, distance is the path you actually take, whereas displacement is that straight line from start to finish, just like this previous slide had. Whoop, that's not the previous slide. Just like the previous slide. Okay, so distance is the path you travel, displacement is that straight line from start to finish. All right, and then last one, how would you measure the height, would you measure the height of a building in meters? Why or why not? Well, meters is like a yardstick. Okay, in America, of course, we use yards. We don't use that in science, though. So meter is almost the same as a yard. So we're looking at about, about something like this. So would we use this to measure the height of a building? I think that would be fine. I mean, unless you have some super high skyscraper, but even then, using kilometers would be a little bit of a stretch. Now, there are units between meters and kilometers, like there's a hectometer, a decameter, things like that. But the main basic units we'll talk about in here are really kilometers, meters, centimeters, things like that. So I would say yes, that would be a great thing to measure the height of a great unit to measure the height of the building with, because you're not going to have too many of them. Like I think if we measured the height of this wall right here in meters, that would be the perfect unit to use. All right, so hopefully you know the difference in distance and displacement now.